Hello everyone, this is Subham Kumar and I am going to discuss about distributed coordination. The topics which we are going to discuss in this are event ordering and mutual exclusion. Event ordering. Coordination of requests requires events to be ordered. In this, we have two types of systems, standalone systems and distributed systems. In standalone systems, it has shared clock memory and it uses a timestamp to determine ordering. While in case of distributed systems, we have no global clock and each clock runs at different speeds. How do we order events running on physically separated devices? This is done using messages. Event ordering happens before relation. If A and B are events in the same process and A executed before B, then it is represented as A arrow B. If A is a message sent and B is when the message is received, then it is represented as A arrow B. Happen before relationship. From the figure, we can see that in case of ordered event, it is represented as P1 precedes, Q4 precedes, etc. While in case of unordered event, it is represented as Q0 is concurrent with, Q5 is concurrent with, etc. Happen before and total event ordering. Define a notion of event ordering such that if A arrow B, then A precedes B. If A and B are concurrent events, then nothing can be said about the ordering of A and B. Solution. Each processor I maintains a logical clock LCI. When an event occurs locally, its value is incremented and it is represented as plus plus LCI. When processor X sends a message to Y, it also sends LCX in this message. When Y receives this message, it represents it using the following notation. Mutual exclusion centralized approach. One process in the system coordinates mutual exclusion. Client send a request to the controller, wait for reply. When reply comes, back enter to the critical section. When finished, send release to the controller. On controller side, receives a request. If mutex is available, immediately send a reply. Otherwise, queue request. Receive a release from current user. Remove next request. This is the pictorial representation of the centralized approach. Mutual exclusion decentralized approach. Requester K generate a timestamp Ts. Mutual exclusion decentralized approach. Requester K generate a timestamp Tsk. Send request K and Tsk to all processes. Wait for a reply from all processes. Enter CS. Process K receives a request. Defer reply if already in CS. Else, if we don't want in, send reply. If TSR is less than TSK, send reply to R, else defer the reply. This is the pictorial representation of decentralized approach. Distributed control versus central control. Distributed control is easier and more fault tolerant than central control. Distributed control is harder and more fault tolerant than central control. Distributed control is easier but less fault tolerant than central control. Distributed control is harder but less fault tolerant than central control. These are the references. Thank you.